Inside your computer, behind the desktop and underneath the operating system is the kernel. And the kernel runs code called drivers that facilitate communication between the hardware and software like the operating system your computer runs. What that means is these drivers offer extreme full control and complete access to the computer. Now, that means that hackers, threat actors, and adversaries love trying to gain access and manipulate kernel drivers. So one technique in modern malware campaigns is to bring your own vulnerable driver, or BYOVD. That's where the hacker, the threat actor, and the adversary will purposefully place a vulnerable driver in the environment so that they can compromise it. They can hack into it, and then they will have full control over the machine. It is an attractive target for attackers. Kernel drivers are the keys to the kingdom. Because of this, and because kernel drivers can be abused, Microsoft implemented signature enforcement for kernel drivers to enhance system security. That means that by default, you can't load any unsigned drivers without setting it from the boot menu, as in physical access to the device. But if a hacker were to bring their own vulnerable driver into the environment that is legitimately signed, like a real trusted kernel driver, that they can manipulate it, abuse it, and then do whatever they want with that full control of the machine. Now, we've seen this across the whole industry. We're seeing modern attacks and threats that do this, like Spyboy, some Terminator EDR killer, or AU Kill. Tools that will disable the endpoint detection and response software, or even Blackbyte ransomware that uses this same technique to break into environments. So here's the gimmick. Say that the threat actor dropped their own implant or their malicious code alongside the vulnerable driver on the file system in user mode. Then they'll fire off their implant, their executable, their payload that will load the driver. And then that driver might be, available for use, and especially abuse, where that implant could exploit the vulnerable driver, and then they could do whatever they want with no longer just user mode access, but kernel mode access. Access to the lower components of the whole computer, manipulating memory, doing whatever they want. So what I want to show you in this video is honestly incredible to me. I think it's so cool. It is mind-blowing, where you can see this whole kernel level attack to ultimately gain command and control and do further post-exploitation on a target. It's so cool. Let's do it. Let me set some background context on this though. We're going to be manipulating an old driver, and this is actually a CVE in a vulnerability way back from 2015, where there was an Intel Network Adapter Diagnostic Driver, or IQVW64.sys. All these drivers will have that .sys file extension. It turns out this kernel driver was vulnerable, and it could be used for a denial of service or a DOS attack, but you could actually manipulate that even more so and turn it into code execution. But look, if you get to manipulate with drivers, that ultimately means you're sending out these device IO control, or IOCTL. If that's new to you, you can take a look at some of the other videos where we've showcased exploiting vulnerable drivers, specifically HEVD, for some learning and education, and we just recently had a video where we got to chat with some of the maintainers of the LOL drivers project, or living off the land vulnerable drivers that are oftentimes used in attacks and security research. Go check him out. Back to that Intel driver that was susceptible to that denial of service attack with the 2015 CVE. Apparently, a community with the game hacking scene, a lot of the anti-cheat research individuals put together this tool, kdmapper. And you can actually find this on this Unknown Cheats forum post, where they're releasing kdmapper to manually map a driver, like an unsigned driver that you might write, and then actually have it loaded by this vulnerable driver that is legitimately signed by Intel. Check this out. This driver comes as part of the Intel LAN drivers and allows you to copy, read, and write user or kernel mode memory, map physical memory, and perform virtual to physical address translation. Whatever the heck you want. They bundled this up into a tool that will load the vulnerable driver digitally signed by Intel. Now note, this is an old tool. It's from 2019. You can see commits from 4 years ago, and it is outdated and just for educational purposes only, but that is what we want to learn about today. And look, I know there are a whole lot of moving pieces here, but what we're ultimately going to end up doing is manipulating kdmapper and making some changes so it's less likely to be detected by security defenses or automated antivirus EDR engines and all that stuff. And what we will do is actually craft a kernel driver that can execute shellcode to do whatever the heck we want. We'll use this as a proof of concept to gain full compromise of the computer, hack into the device, and get like a command and control agent that will have a callback and access, remote access for future post-exploitation, and we'll do that using Havoc. And by the way, all this like low-level code, the changes, the manipulations, the modifications that we make, they're actually already done for us with the Maldev Academy module in this update 5 for, hey, building and bringing your own vulnerable driver. That is actually where I'm learning all this incredible, crazy cool stuff. Hey, hacking into vulnerable drivers. And look, if you're super interested in this, if you want to get smart on that too, please let me tell you a little bit about Maldev Academy, actually the sponsor of this video and the one that helped me get set up and speedrun this whole demo and showcase. It's crazy cool. Let me tell you about Maldev Academy. Brought to you by the renowned security researchers Mr. Dox and Null, join a comprehensive and module-based malware development course that provides fundamental to advanced level training. Write your own implants, beacons, and malware with modern 64-bit architecture. Perfect for offensive security specialists or even beginners with no prior experience in malware development. With over 100 text-based modules, all with downloadable files and code, and a vibrant Discord community, you learn so much. Between process injection, compile time API hashing, anti-debugging techniques, sandbox detection, and so much more. You're provided a virtual machine that includes all the pre-built tools and code ready for you. And of course, upon completion, you get that fancy certificate that proves all the awesome stuff that you've learned. With Maldev Academy, you can choose any plan for access to the material, or jump into lifetime access and get all the new updates. Both Mr. Dox and Null are always sharing new research between lolbins or other tradecraft, and with Maldev Academy, you can truly become a professional malware developer. Dive into the Academy with my link below in the video description, jh.live/Maldev Academy. For a limited time, you can use my code Hammond10 for 10% off. Huge thanks to Maldev Academy for sponsoring this video. All right, now I am inside of the Maldev Academy virtual machine that comes with all of their coursework and modules, and we can go ahead and manipulate this. Let's follow through with the rest of update 5 here. If we want to actually go ahead and test kdmapper, we could try to just do a simple hello world equivalent for the driver world, like at the kernel level. This is pretty cool. This is pretty easy. Hey, you can just sanity check this with the debug view utility from sysinternals, but the way that we have to do that is just, hey, maybe making a quick change into the registry. I'll copy and paste this for the HKey local machine hive. Under system, current control set control session manager, we need a new key called the bug print filter and set a dword value of hex 8. So we can go ahead and set that up. Let me fire up the registry editor with regedit. Ultimately, you could use probably, I don't know, a simple regadd command or whatever PowerShell that you really want here. But once we navigate to that location, we will need to create a new key, right? And that was debug print filter, I think was the name of it. And now in here, we'll create a new dword value that is called default in all caps, and we'll hit enter to set the value of 8. That should be all that we need, but that does have to be actually forced and set after a reboot. So what I'll do is actually just restart this computer. Okay, that is booting back up. It does automatically log in, nice and easy for us. Perfect. Now I can run the debug view utility from sysinternals. However, we will need administrator privileges to be able to do that. So what I'll do is actually just open up the command prompt, cmd, and I'll hit Control-Shift-Enter to run that as an administrator. And that way I can move back into my desktop. I'll just cdc users maldev, get into my desktop, and then I'll run that debug view 64.exe. Now I'll filter, change what we want to capture to just capture the kernel, and I'll toggle off the pass-through here. Now that that is running, we ultimately want to run kdmapper with our simple hello world.sys kernel driver that just simply outputs hello world at the kernel mode level. Back on the desktop, I have downloaded all of the files that are included with that module, and our hello world source code is here, and the hello world.sys driver is here with us. They also have the updated kdmapper, where they showcase some of the changes that they made to actually make this a little bit less detected and signatured by things antivirus like Windows Defender. But what we'll do is simply extract this. Let me extract all. Here we go. Now that that's in its own folder, we do have a solution file with Visual Studio. I'll just fire that up and make sure we can compile this. Oh, and hey, just a super quick note here. We will need to install and actually have set up the Windows Driver Kit, or WDK, alongside like the Windows SDK, all the software development toolkits and everything that we need. I've already installed that in the virtual machine, but of course, Maldev Academy offers the link and helps you cruise through that. It takes a little bit of time to set it up, but hey, if you can cruise through it, that will let you at least compile kdmapper if you make any changes, and for our own kernel loader that will execute shellcode, we'll need that installed and set up just as well. Now, inside of Visual Studio, we do have our kdmapper solution loaded. You can see everything that's necessary here. I don't know, we could dig into the kdmapper.cpp or the header files if we'd like to explore them. Ultimately, we want to change this build mode into release, and then we can go ahead and build the solution with Control-Shift-B. That will cruise through the compilation process, and finally we will be left with a executable that we can run and consider this our implant. Say that, hey, this is the payload that we want to use to be able to manipulate the vulnerable driver that we might place on the target. So let's get back into our command prompt. Let me go ahead and paste this onto the screen where I will run kdmapper.exe. And we know inside of our byovd directory on our desktop, we also have that hello world.sys executable here. So what I'm going to do is actually move this to the side, and I'll move our debug view on the other side. We'll make sure that we're capturing as we are. And the moment that I hit enter on this, we should just get a simple hello world. Let me fire it up, and here we go. There is our simple hello world just printed out with the kernel mode debug view. Okay, so baby steps. We've at least gotten kernel mode execution, right? Hey, we've loaded our unsigned driver, like our hello world.sys, and we're abusing the, hey, Intel CVE 2015, whatever, legitimately signed Intel driver that is vulnerable and that we can use to do whatever else we want with our own unsigned driver. One thing to note is that this kdmapper proof of concept was seemingly only evidently successful on Windows 10, but did not run on Windows 11. That's a-okay. Our Maldev virtual machine for learning and testing is running Windows 10. Now here is the coolest part. Look, we're not going to be building out our own kernel driver. That would make for an incredibly long video and way too much stuff that isn't really necessary for the scope of what we're digging into right now. And Maldev Academy says the same thing. Look, we're not going to go through all of that in this module, but let's light off some fireworks and show something super cool. Let's use a kernel loader driver that will actually run shellcode and will inject into msmpeng.exe. You know, like Windows Defender, the local antivirus and firewall engine that is always on Windows. What if we inject into that, execute shellcode, and then get a command and control or C2 callback? So we have a couple things at play here. We'll end up building out this kernel loader.sys driver that will decrypt a payload that we can provide, whatever shellcode that we want. And we can actually, hey, maybe encrypt, maybe build out and stage our payload with some other code that Maldev Academy has offered us. And that's nice and easy. It all works out of the box for us. But this kernel loader module will then search for the Defender process ID and then be able to do some crazy injection. It uses APC injection, which is actually different than how it's done in user mode. There's some other tricks that it's using for kernel mode execution, but look, I'm cool with it. I just want to see this thing in action. They do give you all of the source code for the kernel loader if you wanted to get into, hey, maybe more of the internals with the kernel driver itself. But again, this is the component that is our unsigned driver that will load shellcode, but it's being staged and executed by the signed Intel driver as a trusted vulnerable driver. So hey, let's get our command and control server staged by using Havoc. We'll set it up over in our Kali Linux virtual machine, and I do actually have it installed and set up in my op directory. I have Havoc here ready for us. So if I move into that directory, everything that we need is here. But look, part of update 5 for Maldev Academy, where all this cool education modules are coming from. They do include an introduction to the Havoc command and control server. And if we wanted to fire that up, hey, quick and easy, we can just use it and get it running. And hey, big kudos, credit where credit is due. Havoc is put together by Spider or 5 Spider, 5 Piter. One of the other incredible folks, now part of the admin staff for Maldev Academy, alongside Mr. Docs, Null, all those great folks. And they offer their documentation and installation process here online. We can go check that out, but again, you'd need to cruise through this on your own. Thankfully, they've made this super duper easy. It's basically just git clone, grab the repository, the source code, install whatever dependencies, and then use a couple build tools that will spin this thing up. We can go ahead and run Havoc in server mode. We'll copy paste this. Back into Kali Linux, let's just fire that up. We can see it in action here. Oh, that's so cool. Havoc, pwn and elevate until it is done. Now in another terminal down below, let me just /havoc with a client operations. There we go. Name can be whatever Neo, host is ourselves. We can see the port just above in the server side output. That is 40056. User should be Neo, and then password, I think the default is all lowercase password 1234. Let me hit connect here, and there we go. Now we have Havoc C2 all set up and ready for us. Let me say, inside of my Kali Linux virtual machine, I don't think it has the proper font for a lot of the monospace or like terminal text, but that's okay. We can keep cruising. Let me go ahead and view our listeners. And first things first, we need to add or create a listener. We can just call that simple, like https_listener, as that is the mode or payload that we'll be using. We can click add to add our payload, the IP address or the callback where it's actually going to reach back to for the hosts. That is my current IP address in the interface that was able to automatically grab. And basically, that's it. We can just hit save and that'll be up and ready to go. Now that that listener is running, we can go ahead and build out a payload. I'll navigate to the attack section and payload up here. We'll build out a daemon using our HTTPS listener with a 64-bit architecture, but we'll change the format to Windows shellcode. Because again, our kernel loader, that driver, the unsigned driver that gets loaded and fired up by the Intel vulnerable driver, we will end up using shellcode here. I'm fine with these defaults, and we can just go ahead and click generate. Now this takes just a little bit, but it will prompt us for, hey, where do you want to save your shellcode? Okay, there we go. Now we can just save our daemon 64 bin. I'll just slap it in the home directory. Yeah, I don't care. There we go. All right, now we can save our daemon 64-bit bin or some of that shellcode. We'll just slap it into our home directory. Now, ultimately, we need to actually manipulate this payload, right? The shellcode needs to be encrypted with that payload encryptor utility that we saw Maldev Academy trying to get us spun up for. So let me open up the Thunar or the file browser so that I can just copy and paste this out of the virtual machine. Now we can get back to our Windows virtual machine, our Maldev Academy VM, and that is basically acting as kind of our target and really the test bed as to where we're building all this out. So let me go ahead and just paste in the file. There is our daemon 64-bit shellcode, and back in the files that were pertinent to this module, we know that they gave us our payload encryptor. Let me go ahead and extract that, and inside that directory we have the solution file to again open this thing up in Visual Studio and compile and run. Now, payload encryptor is loaded up. We could actually take a look at the main.c or the source code if we wanted to, but all is looking good to me. No errors. We can go ahead and toggle this to release mode and then again, build this solution. All right, now we have the executable in this directory. Let's go ahead and go back to it with our command prompt. Let's just cd to change directory into that location. I'll zoom out just a bit here so I can dir, and you can see our payload encryptor.exe. Now, if I were to clear the screen and say, hey, let's run that payload encryptor.exe, it does need an argument supplied for the payload file. Now we have that shellcode that we have on our desktop, and let's pass in the Maldev desktop, and that is just our simple, daemon x64.bin. I'll hit enter on this, and okay, there we go. It is cruising through all of the encrypted shellcode that we'll just need to copy and paste, and then paste into our KDR or that kernel loader. This is all of the encrypted shellcode that we'll just need to copy and paste to put into our unsigned kernel loader driver. It will then execute that shellcode, inject into Windows Defender, and fire off the Havoc C2 callback. We can simply hit Control-C on this. We don't need to let that whole thing load. So I went ahead and redirected all of that output into just this shellcode.txt file on the desktop. Let me go ahead and copy and paste all of this. And now let's go mess with the source code of our kernel loader. We'll extract that file, open that up in Visual Studio just as well. And remember, you're already given all of this source code. Maldev Academy has just, hey, done all the hard work for you. We can just go ahead and kind of use plug and play here. Remember, you do need WDK or the Windows driver kit to be able to, hey, have all the types and, I don't know, different kinds of variable formats and functions and all the stuff that's included there. So we'll need to make sure that that is an install dependency and all the other stuff. But if we keep scrolling down, if I get to the very, very bottom of this code, we can see the driver entry function where we just print out with the debug. Hey, we could view that with that sysinternals tool again, and it starts to decrypt the payload and then do some of the magic to inject it. We need to actually set up the encrypted payload present here. Now remember, we have this shellcode that's already been given thanks to that payload encryptor utility. Let's just paste that in, but note the variable name needs to be encrypted. I think ours was encrypted shellcode. So let me delete that and just Control V to paste all of this nonsense. We'll scroll all the way up to the very top, and let me just change that variable name to encrypted, remove the word payload there. I'll save that, and let's go ahead and change this to release and build this. Look at that. Now we've built out our driver, kernelloader.sys, and that is our unsigned, unverified driver, but we can go use that kdmapper proof of concept to use the vulnerable driver, that Intel 2015 denial of service thing, to run this and get a callback. All at the kernel level. Let's go try it out. So let's start from a clean slate. I'm just going to open up the command prompt with admin privileges. Let me hop over to the desktop. Let me fire up debug view just so we have it. And now let's stage this command where we will use kdmapper with our vulnerable driver. So what we'll do is we'll use our byovd directory in our kdmapper updated kdmapper directory, x64 release kdmapper. Now, as an argument to kdmapper, we are going to end up using our kernelloader.sys driver. So hey, let's kind of stack these, get these all ready to be seen together. Let's have debug view maybe over on the side here, and let's have the command line down below so that ultimately we can split these side by side. Let's go bring our target Windows virtual machine to the left. Let's bring our Kali Linux side to the right. And that way we could actually go ahead and view these both at the same time. All right, we have everything staged. Now, once I hit enter, the coolest thing in the world is going to happen, right? We're using our vulnerable driver, that Intel 2015 CVE, to load our unsigned driver that will fire off shellcode that injects into Windows Defender, and then, hey, starts a Havoc C2 command and control implant beacon and callback. Let's do it. Let's fire it up. All this kernel mode exploitation here, just like that. Look at this. Hey, debug output driver loaded successfully, found Defender's process ID, found all of this stuff between the open handle that we need, writable memory, and then we fire off our payload, all kernel side. And let me show you this. Look, is Defender running? Yeah. We'll fire it up. Manage settings here. Real-time protection is on. Defender's still kicking. Oh my gosh, that is so cool. Look at this. Hey, go check out our Kali Linux side. We have full system access here. We could go ahead and interact with this agent. We'll do that right quick. Look, this agent is authenticated as system of that machine with the process msmp.exe. Defender. We didn't even have to touch it. Let me run who am I super quick. Task the agent to get all that input. We can see, hey, here is our output of all of the privileges that we might want, because we're literally the system here running from the kernel, well, using the kernel to be able to run this thing out of Defender, which is wild. And you could do whatever usual stuff, like, hey, let me just take a Dumbo screenshot. We could list processes, we could write files, we could, of course, real threat actor, I don't know, continue on our malware campaign. We can check out anything else that we might want to do for our post-exploitation. And again, my font is a little bit wrong over on Kali Linux, but we can run shell commands if you wanted to completely lose all of your OPSEC. You could upload stuff, you could download stuff. Hey, maybe you could check out the services. You could do whatever you want. All because we have that system access game from BYOVD, or bring your own vulnerable driver. Seriously, I think that is one crazy cool technique. Like, that is literally the coolest thing ever, when you get to bring your own vulnerable driver and exploit it and then get kernel mode access, full compromise of the machine. And look, we're learning about all of that with the Maldev Academy and all of the incredible updates that they're continuing to release every single month. And look, if you've got some of that lifetime access to learn all the incredible stuff, you're going to be a malware developer, like hands down, without a doubt. It's so cool to be able to just spin off and kick off this technique. I don't think that there is other material out there like this, at least on YouTube, right? Like, for what I'm doing, trying to set off the fireworks, get this education out there. Like nothing has been that streamlined with code that works out of the box. You can kind of plug and play, and man, you're looking at some crazy cool exploitation and malware techniques. Thank you so much for watching, everybody. I hope you enjoyed this video. I hope you had a whole lot of fun with it, and I hope it blew your mind like it blew mine, and I hope you get a chance to go take a look at Maldev Academy. Link in the video description. They have some incredible stuff, and I hope you go take a look. I'll see you in the next video.